Continue today we will finish today problems on particle equilibrium. The 500 LV crate is hosted using the ropes AB and AC. Each rope can withstand a maximum tension of 2500 lb before it breaks. If AB always remain horizontal, determine the smallest angle theta to which the crate can be housed. So here, whenever they gave you in a problem a maximum tension, this does not mean that the same tension will be in all cables. Okay, it will be in one of these cables. So the issue is to know which cable will have the maximum tension, and then say that I will impose on this cable a tension of 2500 and find the tensions in other cables. Okay? Sometimes it will not be very clear from the figure which cable will have the highest force. This is why, in case it's not clear in the figure what is the cable having the maximum force, I should do an assumption. What do we mean by assumption? I say, here I will explain for you why it is clear that AC will be the highest force, okay? But in case I have another scenario where it's not clear which force is the highest one, I can just do an assumption. I say, let us suppose that AB is the maximum, for example, and I set AB equal to 2500. Now I find all other forces based on this assumption. In case all forces calculated are lower than AB, then I say my assumption is right and I do my calculation. In case I obtain one of the tensions higher than AB, I say then, no, it's wrong, my assumption is wrong. And now, from my calculation, I can determine which one is the highest, and I repeat the calculation based on a new assumption. Okay? I will repeat this. If you have in any problem the sentence that we have a maximum tension that can be sustained of a certain number, okay, then this will happen in one of the cables. Or sometimes if we have symmetry, for example, and we have two cables having same tension, it can happen in two cables. But it will not necessarily happen in all cables. So here, for example, no symmetry, the tension is not equal in the cables, then we will have one cable that will have a force that is higher than the others. This will have the maximum tension. So if you look at this figure here, who can tell me which cable will have the highest tension if we do a small analysis? If you consider the horizontal direction, this tension does not have a projection along the horizontal. You only have TAB, okay? TAB should be lower or higher than TAC to have equilibrium?
Lower.
Lower, because TAC, the projection of TAC, okay, should oppose TAB. And you know that the projection magnitude is always smaller than the force magnitude. This is why, since the projection of TAC should be equal to TAB, then TAC is higher than TAB. And also, if we do the analysis in the vertical direction, in the vertical direction, we have the tension in the third cable, and we have the projection of AC on the vertical. Okay. Also, in this case, the projection should oppose the force, so TAC will be higher than the force here. So, because this problem is relatively simple, I can directly say that the maximum is in TAC. So I put TAC equal to 2500. And once I know the value of TAC, then I can write my system and solve for the other unknowns. Okay? While in case I didn't pay attention for this, I can make an assumption. So for example, in their case, they said, assume TAB equal to 2500. And we will see that they will see that their assumption is wrong. Because when they assume that TAB is 2500, we still have two unknowns, which are we have angle theta is unknown, okay? Theta is unknown, and we have TAC unknown. The third force is known because we know the weight. If you look here at the given, the weight of the crate is given, okay? So here we have the 500 lb crate, so we know that this force here is, the downward force is 500 lb. But what is our problem? Our problem is that we have three unknowns, which are the force F, which is TAB, the force TAC, and the angle theta. So we have three unknowns, and we know that in equilibrium, in 2D equilibrium, I can only write two equilibrium equations. Okay, so I need an additional information to be able to solve my system. The additional information is that the maximum tension that can be in any of the cable is 2500. And since I am designing on the critical case, because they said to determine the smallest angle theta before rupture, then I should do an assumption. I should say, let us suppose or AB or AC equal to 2500. They choose TAB, and then they projected on X and Y. Sum of X equals 0 will give us uh, will give us TAB minus TAC cosine theta equals to 0. And the projection on Y will give us TAC sine theta minus 500 equals to 0. Since they suppose TAB equal to 2500, they end up with two equations with two unknowns, which are TAC and theta. Okay? And by solving this system, they will get TAC equal to 2550, which is higher than 2500. So now they can say our assumption is wrong. Okay, and from here we are sure that the maximum is not in TAB, the maximum in TAC. So they repeated the calculation, and now, of course, they will do the true assumption that TAC is equal to 2500. Then repeat the projection along X and Y to have a new system of two equations, two unknowns, and they can get the value of theta and the value of TAB. And you can make sure now that TAB is smaller than 2500. Okay? But of course, if you do a small analysis on the figure, you can directly know that TAC is higher. So you can directly start by the good assumption that TAC is equal to 2500. Okay? Any question on this? And look here, why they said the smallest angle before rupture? Because as we said last time, when I decrease the angle, okay, in order to maintain equilibrium, the tension should increase, because what will support the weight is the vertical projection of TAC. And the vertical projection of TAC is equal to what? Is equal to TAC sine theta. So as you decrease the angle, what will happen is that sine theta will be reduced, and TAC should be increased to support the crane. Okay, this is why if we decrease more theta, TAC will be higher than 2500, and we will have rupture of the cable. Any question on this problem? Okay.
Doctor,
Yes.
I understood the method, but can you just repeat the given? Because I did not understand that I needed to do that.
Okay. They said that we have a crate, okay, of weight 500 lb that is supported by a system of cables, okay? Then they said each rope can withstand a maximum tension of 2500 lb before it breaks, okay? So this means that when you design your system, you should not exceed in any of the cables the value of 2500. Then they asked you, what is the smallest angle theta that can be, to which the crate can be hosted without rupture? When they talk about a critical case, when they say the smallest angle will correspond to the maximum tension. okay? Because you are designing based on the critical condition. So when they say this sentence, you know that you want to design your system in a way to not to just be at the limit of rupture. The limit of rupture is when you reach in one of your cables a tension of 2,500. Okay. Now, if you paid attention at the figures that TAC is the highest, you directly start by the right assumption. You say TAC should be is the highest force, so it will reach first the maximum. Then you set TAC equal to 2,500. And based on this, you calculate the corresponding smallest value of that. Okay?
Yes, thank you.
Yes. Okay. The last problem of chapter 3 determines the magnitude of P and the coordinate direction angles of F3 required for equilibrium of the particle. Note that F3 is in the octant shown. So this is a typical problem of equilibrium. You have a particle that is subjected to several forces, okay, and you have a certain number of unknowns to find. First, what are our unknowns? All our unknown are related to F3, okay, because for F3 we just know the magnitude, but we don't know the direction angles. We don't know, if you want, anything about direction. Alpha, beta, gamma are unknowns. So here we have three unknowns for F3, which are the direction angle, the angles with the three axes, X, Y, and Z. And you know that in a 3D equilibrium, we can write three equations: sum of X equals 0, sum of Y equals 0, and sum of Z equals 0. So I am able to solve three equations with three unknowns. Whenever I have such a problem, the first step to do is to find an expression of all my forces, then to replace in the vectorial relation. The vectorial relation is that for equilibrium, sum of forces vectors should be 0. What are my forces here? I have F1 vector plus F2 vector plus F3 vector plus F4 vector and plus P vector equal to 0. Okay, so this is my vectorial relation. Okay, all I have to do now is to decompose it into three components: X, Y, and Z. Okay, or even you can keep it in vectorial form. You do the summation, you take the I component together, you say that they should be equal to 0, the J component together should be equal to 0, and the K component together should be equal to 0. So now, in order to be able to write my three equations, all I have to do is to find the expression of all my forces. To start with, P is very simple, as you can see here. So look here, another unknown is P, okay? So the magnitude of P is not known. So until now, we have the magnitude of P that is unknown, and we have the three angles of F3. We have the angle of F3 with X, the angle of F3 with Y, and with Y axis, and the angle of F3 with Z. So until now, we have four unknowns. But why it's not a problem? What is the additional equation I can use here to close my system?
Sum of cosine square
Very
is
good.
equal to 0.
Exactly. If you remember, when we talked about direction angles, we said that there is a relation between the direction angles. Cosine square alpha plus cosine square beta plus cosine square gamma equals to 1. And we said that the only problem is that for cosine square, I should determine the sign. I take the positive value if I have an angle lower than 90, and a negative value if the angle is higher than 90. And here I don't have this problem because I know the octant. Because look, they said F3 act in the octant shown. In this octant shown, as you can see here, X is positive. So this means what? This means that the angle with x will be smaller
Uh,
than 90.
yes,
Okay.
yes.
Now, the projection on y is negative. So this means that the angle with y will be higher than 90. And also the projection on z, okay, is also negative. So the angle with z is also higher than 90. So here I know the angle interval, and I have four relations here: three equilibrium relation and the cosine relation. So I will have four equations with four angles. Okay. So now, first, let us continue. So for p vector, how I will write p vector? P as a vector is equal to p cosine 20 along I, okay? Sorry, along j, because it is in plane yz. P is in plane yz, okay? So it's p cosine 20j plus p sine 20k. Okay. Now, the second force is F1. For F1, what do I know? I know the magnitude, and what else is given? I have,
Coordinates.
it's passing by the origin, and it's passing by this point. Okay. So what method I should use to find F1 vector?
F1 multiplied by the unit vector.
Exactly. I should use the unit vector. So I will say that F1 vector is equal to F1 magnitude, which is 360, times the unit vector of F1. And the unit vector of F1 has as coordinates of the vector are minus 1i, minus 7j, plus 4k over the magnitude. Okay, so it's 360 times minus I minus 7j plus 4k over radical of 1 square plus 7 square plus 4 square. Okay, so this is F1 is completely a known vector. Now, what about F2? If I look at my figure, F2 is the simplest force. It's along y axis in the negative direction. So F2 vector is equal to 120 minus 120 j. And finally, for F3, what I can write about F3 is that F3 is equal to 200 cosine alpha along I plus 200 cosine theta along j plus 200 cosine gamma along k. Okay, and now the fourth relation that will the relation that can close my system is the relation between alpha, theta, and gamma, which is cosine square alpha, okay, plus cosine square theta plus cosine square gamma equals to 1. Okay, so let us look here at our system. You can see what we did. They did the same method. They found the different vectors. Then they wrote first sum of x equals 0. Okay. In sum of x equals 0, I take the component of f1 along I, which is minus 44.313. What other force has a component along x? It is fx. Okay. F3 xi. So from here I can find the value of f3x. Okay, and you know that f3x is what? f3x is f3 cosine theta. So if you want, what you can do, you can first find f3x, okay? Then say that f3x is simply equal to f3 cosine. We name the angle alpha, and since you know the magnitude of f3, which is 200, okay, you can from this relation get the value of alpha. Now, if we continue, sum of y. In sum of y, we take the y component of f1, which is minus 310.191. We have f2 is along minus y, so it's minus 120. For f3, we take f3y. And for P has a component along J, which is P cosine 20. So we get the following equation. In this equation, we have two unknowns, which are Fy and F3y and P. Okay? Now, we continue with sum of Z equal to 0. In sum of Z equal to 0, we take Z components of all forces. So we have 177.252. We have minus 300K, which is F4. And we have F3 along Z. So plus F3Z equals to 0. What we can do here, okay, here what we should do an additional equation. The additional equation, or we use the cosine square equal 1, or the other method you can use is to say, since I know the magnitude of my force, okay, I can say that 200 is the radical of fx square plus fy square plus fd square. And this is equivalent to the cosine square rule, okay? The only difference is that I multiplied by the magnitude of the force. Because look, مش نحن عنا إنه 1 is equal to cosine square theta, cosine square alpha plus cosine square theta plus cosine square gamma. If you multiply this relation by 200, which is the magnitude of your force, you get that 200 is the radical of fx square plus fy square plus fg square. So here you can use this formula instead, which is the magnitude of your force. So this will give you an additional equation, okay? This additional equation will close your system. From here, you can find the value of P and F3Y and F3Z. Once you know all components of your forces, and here note that in your solution, you have to choose between a positive and a negative value, like the cosine. So you have two possibilities. You have Fy to be negative or Fy to be positive. But here you will select the solution. In this case, you will select the value that correspond to the octant you have. Okay. So since you know in your problem that you have a negative Fy, so you will select this solution, and based on this, you can calculate the value of Fz. Okay. And once we know the value of Fx, Fy, Fz, we can now calculate our angles by saying that alpha is cosine minus 1 Fx over the magnitude, beta is cosine minus 1 Fy over the magnitude, and gamma is cosine minus 1 Fz over the magnitude. And as we said, alpha is smaller than 90, beta is higher than 90, and gamma is higher than 90. For F3, how did we project along the y-axis? Yes, Marisa, let us go back to the figure. If you look here on the figure, okay, F3 vector, they show you the projections along the three axes. Because look, this line here represents the projection along Z, okay? It's clear that the projection of F3 along Z is negative, okay? And the projection of it along X is this one, okay, which is positive, and the projection of it along y is this one, which is negative. So from the figure, from these lines, you can see that F3 has positive projection along x and negative projection along z and y. Okay, Marisa?
Doctor, sorry, I still didn't understand إنه ما بعرف ما فهمت these lines كيف عرفنا إنه زاد لتحت
Okay.
and
Okay.
I usually don't do it هيك.
Yes. Look, you what is the starting point of your force? It's the origin, مظبوط? This is your starting point. This is your end point. Okay? If you want to project in general on a certain axis, if you don't see it here, do the projection. يعني, if you do the projection on this side like this, okay? The parallel to this one. It's parallel to this one. It will be you go from this point towards the projection of this one. Okay? So you go from the origin towards the projection of the other point. It's in the negative direction. Okay? Look, it's pointing downward. It's clear. So here you will go always from, if you want the projection, you have here, if you draw this triangle here, if you have a vector.
F3 is not going along X.
No, of course it's not going along X. Look, you have a certain angle with X. Okay? It's going from the origin towards a certain point. And then this point, if you project this point, okay, you can know the component of this point. This point has a negative component along Z, okay? It has a positive component along X, and it has a negative component along Y. So if you want, the unit vector of the force is the one joining the origin to this point. So, and since vector OP here, from vector OP, you can know if the components are positive or negative. OP, okay, has a negative component along Z, because if you do the projection for the point here, okay, this point has a negative Z, مظبوط? How to find Z? You take this value, and it is below the XY plane, so it's negative, okay? And for X, what is X component of this point? This is the X component of the point. It's a positive component, okay? While what is Y of the point? This is Y of the point. It's negative also. This is why F3 will have negative component along Y, negative component along Z, positive component along X.
Okay. Thank you, doctor.
Welcome. Any other question? Okay, so we are done with this chapter, and we will start the final chapter for the exam, which is moment and forces. Okay, I will open a new session to start the new chapter.